Find the following loci. Describe any geometrical restrictions. Okay, for the first one, x equals 3 and y equals p squared plus 4. So, I have x equals 3, and this is not affected by any value of the parameter p. So I can say that x equals 3 is independent of p. So whatever value of p I put in, I'm always going to have x equals 3. So therefore x equals 3 is going to be my locus here. However, that's not the whole story in this case. If we look at the y condition, we have that y equals p squared plus 4. Now for any value of p that I substitute into this, p squared is always going to be positive, and so p squared plus 4 is always going to be greater than 4. So I can say, but y equals p squared plus 4 is always greater than or equal to 4. So therefore, the locus is x equal to 3, and, or maybe I should say where, y is greater than or equal to 4. So what would that look like? That would look something like this. Let's say that this is x equal to 3, maybe that's y equal to 4, and my locus looks like this. So this is the point 3, 4. Okay? Alright, the next one. X equals 1 over p squared plus 1, and y equals 2p over 1 plus p squared. Okay, so I want to eliminate this p squared plus 1 business. In fact, I want to eliminate all the p's. I want to try and find a relationship between x and y. So, what will I do here? Well, I can see that I pretty much have x in this y. I have this 1 on 1 plus p squared, which I have here, but I also have a 2p. But for the moment, I'm just going to eliminate as much of the p as I can. So, I have 2p times 1 on 1 plus p squared, which is the same as 2p multiplied by x. That's what y is, and so therefore, I want to get p by itself, so I'll have p equal to y on 2x. Now, I have an expression for p in terms of y and x. I can substitute that into either of these. It'll probably be best if I substitute it into this one. So, x equals 1 divided by p squared, which is y on 2x, so y on 2x squared, plus 1. Okay, now let's see what I can get from here. That will mean that x equals 1 divided by y squared on 4x squared plus 1. If I multiply the numerator and the denominator by 4x squared, I'll have 4x squared equals y squared plus 4x squared equals x. Now cancelling an x here with an x here, so I'll get rid of the squared, and then I'm going to multiply this up here. I'll have y squared plus 4x squared equals 4x. Is this the entire story in this question? Not quite. Here I can note that for any value of p which I put in, this whole term here is going to be positive and non-zero. So I could say that x has to be greater than or equal to 0. It's always going to be positive, and it's always going to be greater than 0. I shouldn't have strict inequality here, so strictly greater than 0. Okay, final part. What is it? X equals p plus q. Y equals p squared plus q squared. And I also have another condition that p multiplied by q equals 2. Okay? I want to find a relationship between x and y. Now, where's that going to come from? Well, the trick with these types of questions, and you should try to learn this trick because it comes up in parametrics and it comes up in polynomials and often in other algebraic manipulations. But when I see a p plus q and a p squared plus q squared, I have to consider what is p plus q all squared. Well, that's the first term squared plus the last term squared plus 2 times the product of the two terms. And what do I see? I see p squared plus q squared right here, so that's going to be y. And I see a pq, 2pq, and I have a pq. So, p plus q all squared, well that's x squared. P squared plus q squared is y, so here I have p squared plus q squared, that gives me y. And here I have pq, and pq is equal to 2. So I have plus 2 times 2, which is 4. So here's my locus. But, once again, that's not the whole story here. Because if I say pq equals 2, that would be the same as saying that q equals 2 divided by p. And I could substitute this expression into this for y. And what does that give me? That means that y equals p squared plus 4 on p squared. So I've just squared the q, which is 2 on p, and squaring that gives me 4 on p squared. Okay, so I have that, but what does that mean? Well, again, it's not really that intuitive to see, but you just have to have a bit of familiarity with it. Let me consider how I can get this expression here. Now I can get that from either p plus 2 on p, and then squaring it, or p minus 2 on p, and then squaring it. And here we're going to work with the minus. And I know that this is always going to be greater than or equal to 0. So what does that tell me? It tells me that p squared minus 2 times p times 2 on p. So the p's will cancel. I'm left with negative 2 times 2, which is 4. Plus the last term squared is 4. That's a 4 on p squared is greater than or equal to 0. So in other words, p squared plus 4 on p squared is greater than or equal to 4. But what's this? That's equal to y. So I'm saying that y is greater than or equal to 4. Now, if I put that into this, what do I get? I get x squared is greater than or equal to 4 plus 4, which is 8. Okay, now, what does that tell me? Well, if I'm graphing x squared, it has to be greater than or equal to 8. So 8 is somewhere here. I drop these down, and it has to be here or here. So this tells me that x is less than or equal to negative 2 root 2, because if I substitute 2 root 2 into x squared, that gives me 8. In other words, that's the x coordinate when y is equal to 8. Or I also have x is greater than or equal to 2 root 2. So I have this restriction for this locus here. And that's the final answer.